Alright, so I was playing with this while you guys were gone, and I was looking at the number of partitions for large numbers. Well, I started small, but then I got large, and I was looking for, when I generated the highest numbers. So, for example, 330,330 has 6,181 different prime partitions, and that's more than any number below it. And that record doesn't get beat until you get to 351,120. That has 6,362.
Cool.
This is kind of an interesting list of numbers. What are some things you notice about the numbers on this list?
Well, there's a few numbers in the list, like this one up here, that have sort of repeating digits.
Okay.
Like 330, 330.
Yeah.
510, 510, 480, 480.
Yeah, hold on a second. I'm sure 510, 510 maybe. Oh, it did. Yeah, 510, 510.
Like 450, 450, 390, 390, 360, 360.
Yeah.
420, 420.
It's really surprising, isn't it?
Yeah.
That those numbers appear, and kind of an odd pattern. And I went and looked in Mathematica, and I did a little factor integer trick in Mathematica. So the ones at the bottom, so I started at 438, 900, 450, 450, 471, 240, and here are their factorizations. So the first one is for 438,900, 2 squared times 3 to the 1 times 5 squared times 7 to the 1 times 11 to the 1 times 19 to the 1. And then all the way down to the bottom, 510, 510 is 2 times 3 times 5 times 7 times 11 times 13 times 17. So what are some things that you notice about these factorizations?
Well, they're using all the primes below, like, well, except for this one and this one. But some of them are using all the primes, like below 13 and here below 17.
Yeah, so this one's 450, 450, 450,000, 450, 510,000, 510. So what else do you notice? Like, so these numbers are in the between 400,000 and just a little over 500,000. What can you say about the prime factorizations of these numbers?
Well, they're pretty easy prime factorizations.
Yeah.
I think it's surprising.
Not very complicated. They use small primes.
Yeah. So there's some interesting thing going on. And by the way, I myself am not totally sure what it is with these really straightforward prime factorizations and having lots of ways to sum up to make the sum of a number via 2 primes. What do you think multiplying out the prime factorizations and summing 2 primes together have to do with each other?
Well, you have the prime. Well, it's multiplication and addition.
Yeah, it's multiplication and addition. Do those things usually have much to do with each other?
Nope.
No.
Not really.
So this was initially, and still somewhat, very surprising to me.
Yeah.
And we can talk about this another time. Actually, my friend online, Chris Long, actually probably pointed me to it. And this video also kind of hints at it a little bit, the other number file video. But what I want to do now is zoom in around a number that has a lot of factorizations. Or not a lot of factorizations, a lot of
Partitions.
A lot of different partitions. So here's the comet up to 10,000. Okay? Or if you want, we could zoom in on one of these numbers down here. Would you rather zoom in around a number below 10,000, or would you rather zoom in on one of these big partitions?
How about below 10,000?
Okay. Now remember, the x-axis actually is divided by 2, so this really ends in 10,000.
Yeah.
Okay, so what's a number that looks like it has a very high number, like one that's up near the top of the comet? That one there? All
maybe,
right.
so maybe be like 8,000, I mean like 9,000?
Well, let's zoom in and go from 8,000 to 10,000. That'll help us zoom in a little bit. Did that do it?
You have to click the comment thing?
Maybe it just ran so fast. Oh yeah, it did. Okay, and it looks like the highest point here is around 600, so that means 8,000 plus 1,200?
It's 9,200.
So 9,200. Let's go 9,200 to maybe, well, it looks like it is right around 600, so let's go to 9,200 to maybe 9,000.
400?
9,000, Oh, let's go to 9,300 and see if we see something that's above 300. Okay. Oh, there it is. All right, so let's zoom in a little more in the next video.
All right.